All right, here in example 4, we're going to find some limit values numerically by making a table of values on our graphing calculator. We'll start in part A. We're going to find the limit as x approaches 2 of x squared minus 4 over x squared minus 6x plus 8. Now, we're going to build a table, and I've put a table in here below to kind of guide us in our mission. But since we're finding the value of the limit as x approaches 2, we're going to create a table with 2 in the middle of it, and we want to get a lot of values that are really close to 2. And what I recommend is that you use increments in your table of 1/1000th here, or 0.001. So I'm going to build my table to go up to 2.001, 2.002, 2.003, and in the other direction 1.999, 1.998, and 1.997. And I'm going to use my graphing calculator to help me create this table. So I'm just going to pull up my calculator, go to the y equals screen, and I'm going to enter the function that I'm finding the limit of. X squared minus 4 over x squared minus 6x plus 8. I'm going to go ahead and enter that in. And then I'm going to go to table set. And in table set, I want to set up, since my table here starts at 1.997, I'm going to go ahead and put that as my starting value for my table. And my delta table is the increment, so I'm going to put 0.001 in there. And I'm going to leave the independent and dependent variables as automatic. And then my calculator will generate my table for me. So I'll now click Table, hitting Second Graph. And it gives me all the values that I need in my table. So I've got negative 1.996, negative 1.997, negative 1.999, error, negative 2.002, negative 2.003, and negative 2.005. And the fact that we have an error here, this is one that if we had tried to handle it algebraically would have led to a 0 over 0 situation. But what I'm going to do now is I'm going to consider what's happening to these values of f of x as I get closer to 2 from the left, and what's happening to f of x as I get closer to 2 from the right. And these values appear, as I get from the left, they appear to be approaching negative 2. These values from the right also appear to be approaching negative 2. And so I'm going to draw from this table the conclusion that this limit is going to be negative 2. Okay? Let's try the same thing. We'll do example B. We'll go in and change over our function. So we've got x squared plus 3x, having some typing issues, 3x minus 3 over x squared plus 5x plus 6. And now for my table, since we're approaching negative 3, I want to approach it from both the right and the left, again using a small increment. And so I'm going to set up my table, go back to my table setup screen, and I want it to start at negative 3.003. And now I'll look at the table, and I get a whole lot of values. Negative 994, negative 1494, negative 2994, error, 3006, 1506, and 1006. And now I consider what's happening as I approach negative 3 from the left what's happening as I approach negative 3 from the right. As I approach it from the left, I'm getting bigger and bigger negative values for my function. And so from this side, the value of f of x is approaching negative infinity. And from the right side, I'm getting bigger and bigger positive values as I get closer and closer to negative 3. And so from this side, I'm approaching positive infinity. In this case, since the limit does not approach the same finite value from both sides, I'm just going to say that this limit does not exist. And you will frequently abbreviate that DNE. Okay, let's go down to part C. Limit as x goes to 0 of sine of x over x. I want the limit as I approach 0, so I'll set up my table around 0. And type my function in. So I got sine of x over x. And I'm just going to verify quickly that I'm in radian mode since I'm working with a trig function, and I am. And then I'll set up my table, start it up at negative 0.003, keep the same increment, and look at my table. And we have all these values, 1, 1, 1, error, 1, 1, 1. And if I go over and I can use my right arrow to look at the values that are in the y column, you see that they're not actually equal to 1, but as I get closer and closer to 0 from both sides, this value gets closer and closer to 1. So we're approaching 1 from this side, we're approaching 1 from this side, so our limit here will be 1. All right, and the last one, the limit as x approaches 0 of x plus sine of 2x all over x. Do the same thing. Set up our table since we're approaching 0. Set up our table as such. And now we just need to enter our function in. In the y equals screen, we've got x plus sine of 2x over x. My table should be set already. Yep. And now I look at the table. And again, the same kind of situation happens here where everything in that right-hand column reads 3. But if we actually scroll down through the y values, you see that they're just rounding to 3. And as we get closer and closer from the left-hand side, they're approaching 3. So from this side, we're approaching 3. From this side, we're approaching 3. And therefore, our limit is 3. And that's the end of example 4 and the end of our lesson on an introduction to limits.